before the White Defense Paper Review of 1957, which doomed many a manned aircraft project for Britain. There were many designs put forth by its aero industry to satisfy a new interceptor requirement known as F.155T. Among the many design submissions was a large and powerful high-performance jet and rocket combination propulsion scheme aircraft proposed as the P.187 by Saunders-Roe, SARO. The project, like many others of the period, only made it to the paper airplane stage for its time in Cold War history, 1947 to 1991. Fresh off the heels of World War II, 1939 to 1945, the world entered into a new global conflict, the Cold War, which pitted East versus West philosophies, politics, and military might against one another. For the West, led by such powers as the United States, Britain, and a rebuilding France, the major threat that soon emerged was the high-speed, high-flying nuclear-capable bomber of the Soviet Air Force. In response there was heavy investment in interceptor types, particularly those centered on turbojet power, to counter the threat and, for the British, this led to requirements like F.155T. To this point, early to mid-1950s, Saunders-Roe had completed a good deal of research and physical work in the realm of turbojet and rocket-assisted aircraft types. The SR.53 was of particular note as it served as a single-seat, single-engine high-performance interceptor, in prototype form, which failed to garner the needed support of British authorities mainly due to the advance of ground-based enemy missile technology, rendering the once untouchable interceptors moot. Nevertheless, two flyable examples of this aircraft were completed by SARO, and the data collected during the program heavily influenced the design of what would become the P.187 project airplane. The assistance provided by SR.53 was notable, for it was to enable SARO engineers to get a working product into the air in the shortest amount of time possible en route to initial operating capability, IOC. Beyond its general form, which only superficially followed that of the SR.53, the P.187 would be wholly unique. It would carry a crew of two, pilot and navigator, and house radar in its nose section, an assembly that was designed to slide so as to provide enhanced vision out of the cockpits when landing, taking off and general ground running actions, while become streamlined when the aircraft was in flight to maintain aerodynamic efficiency, similar to the feature used in the later aerospatial, BAC Concorde supersonic airliner. The aircraft had a deep, portly body in its side profile, and this was partly due to the engine placement within the fuselage, set low and against the sides with aspiration. Each component was bifurcated, split, had under the cockpit floor line and exhausting through ports located under, and ahead, of the tail section. The tail section was given a single vertical fin with the horizontal planes seated at the absolute top of the structure. Air brakes would be installed at either side of the rear fuselage. Ground running was to be handled by a heavy-duty, wheeled tricycle arrangement with a dual-wheeled nose leg and dual-wheeled, in-line, main legs, all retracting into the body. The main planes were clipped deltas with sweep back found along their leading edge, and the trailing edges would be straight-lined. The clipped nature of the wingtips allowed for mounting of wingtip missiles. Control surfaces would line the trailing edges of the main plane members, and the complete unit would be mid-mounted along the sides of the fuselage, each given noticeable anhedral, downward angle. The cockpit was drawn up to seat its crew side by side, though the heavier glazing found at the pilot's position. Because of the speeds and altitudes at play, an ejection system and pressurization figured into the mix. To propel this oversized interceptor, a full complement of turbojet engines supplemented by rocket power would be in play. 2x de Havilland PS.52 gyro, an increased pressure ratio, afterburning turbojet engines of 35,000 pounds thrust, and no fewer than 4x de Havilland Spectre 5 series rocket boosters of 10,000 pounds thrust. The turbojets would set under the aircraft as normal with the Spectre boosters installed over them, under the tail unit, in a side-by-side arrangement. Collectively, and coupled with the streamlined form of the fuselage, the aircraft was expected to reach speeds near Mach 2.5, at altitude, or a rather impressive 1,855 miles per hour. To satisfy the actual air-to-air interceptor portion of the requirement, the P.187 was to make use of two advanced air-to-air missiles, AMS, of the period, Blue Jay Mk.4 and Red Dean. There would be 4 total AMS missiles carried by the aircraft, 2 of each kind, these set to cover radar-guided and infrared types, with a hardpoint found at each wingtip, for the Red Dean missiles, and a single hardpoint under each wing, for the Blue Jay missiles. As drawn up, P.187 sported an estimated empty weight of 55,000 pounds with a maximum takeoff weight, MTOW, nearing 97,000 pounds. Overall length reached 83.5 feet with a wingspan of 51.6 feet and a height of 21.7 feet. Additional estimates rated the aircraft to altitudes greater than 60,000 feet with an intercepting range out to 260 miles. For the F.155T requirement, this aerial machine was not only powerful for the period but also quite large and heavy and would have made for an impressive design should it have come to fruition. However, as promising as it was not furthered beyond its line drawings. Plans were had for additional engineering work to be had, including wind tunnel testing, but all this came to naught, mainly due to the 1957 Defense Review, which saw a future battlefield dominated by air-to-air and surface-to-air missiles.